So my name is Dr. Sanjoy Som. I work down the street. I work at NASA. And, well, who am I? Well, I am who you guys were only like 20 years ago. And you guys can be me very easily 20 years from now. Right, so I can tap this, move slides. Oh, wow. So this guy, that's me in 4th grade. Right? Come back, cute. So my favorite topic back then, my favorite subject was history. I was not very good at math. As you can see, I like chips a lot. I still do. My hair is as bad then as it is now. And, but I was really excited about science. And although I was not very good at math and stuff, I really enjoyed studying it, looking at it. And I just got better over time, to the point where I was telling my friends when I was near in high school, I want to work at NASA. And they were making fun of me because I come from far away, in a country called Switzerland, in the middle of Europe. And we don't have NASA, right? And you're like, you want to do what? So when I was 19, I packed my bags. I'm like, so long, friends, family. I moved to Florida, because that's where Kennedy Space Center is, right? Where all the shuttle launches. And I went to college there. And I studied engineering, so I got better at math. And then I realized after my college degree that I had more questions than I had answers. So I moved from Florida, and I didn't like the weather. It's always hot and humid. So I moved all the way as far to Seattle, where I continued going to school. And that's when I realized that the more you know, the more you realize you don't know. So the job I get now as a scientist is one of continual search, trying to continuing to find answers to questions that we all think about, such as, are we alone in the universe? Where does life come from? This is what an astrobiologist does. So after Seattle, I moved to the Bay Area, which is where I am now, and talking to you guys. Tap the screen, tap the screen. Okay, so when I was in high school, this happened. This is the rover Sojourner. So that landed in about 1997. It's not very big, it's about this size, right? And it was the first time in 30 years that humanity, us, returned to Mars, to the surface of Mars, and we took this, one of the early pictures is this. So what you can see, right, it's a red planet, the butterscotch sky. The main rocks that you see there are igneous rocks. You guys all know what igneous rocks are? Yeah. Right, you guys are all experts. Excellent. But so, when I was a kid, we had this dinky little rover. You guys are a lot luckier, touch the screen. Because you guys, in this summer, this guy is landing there. This is the Mars Science Laboratory, called Curiosity. It's a big, beefy rover with a bunch of cool science instruments. This is what landed when I was in high school.
I want that one.
And then this guy here is is it Spirit or is it Opportunity? You guys think?
Wait, what's Opportunity?
Oh, so you guys are almost right, in the sense that it's both, because they're twins, like they're completely identical. And Spirit, who is not working anymore, it died about 2 years ago. It's broken. But Opportunity is still going. 9 years into its lifetime on Mars, it's still roving quite nicely. Mr. Hill, what is your, with regards to the questions, should we just take them now or at the end, or what is?
I'll let you decide. You can. Sometimes what works best is I'll take one question and save the rest for later, or just wait to the end. It depends how much time you have. You'll get a lot of questions.
I'm very excited about
very curious class.
So anyways, you guys are very lucky because this guy is going, and where is it going?
Mars.
Mars, right? Tap the screen. But this is Mars. I saw this in a poster earlier. So this is Mars, beautiful red planet. It has an incredible landform on the surface, is this guy. It's called Valles Marineris. It is the biggest canyon in the entire solar system, right? And it's as long as America is wide, right? So if you put the canyon on the United States, New York would be here, and San Francisco would be there. So, yeah, it's huge. And what's cool about Mars is that in the late 90s, NASA sent a spacecraft that was able to measure the elevation differences on the planet, right? Then we got a map that tells us about how high and low everything is, right? So think of blue as low and white as really high, right? So you see the canyon there, that's Valles Marineris again. Mars has 3 big volcanoes.
Sorry.
But it also has Olympus Mons. This is the biggest volcano in the entire solar system, right? Mars is a small planet, and yet it has a huge canyon, one giant volcano, and I see one question. If you have a quick question.
I never knew that there was actually active. Wait, are the volcanoes active?
Very good question. They are not. Mars is as old as Earth, and because it's so small, it cooled faster, and now it's just not doing much. But back when it was young, it was very powerful. Let me try and show you how big this volcano is. What is the tallest mountain on Earth? Yes, Mount Everest, right. Actually, this is the tallest mountain measured from the surface of the Earth up to its summit. The tallest mountain on Earth actually is Mauna Kea, which is on the island of Hawaii, because you measure it from under the seafloor, where it's at, all the way to the top. Mount Everest is about 5.5 miles high, right? Mauna Kea, about 6 1/3 miles high. Olympus Mons, 15 miles high. You can see I can't even fit the entire volcano on my slide, it's so big, right? And it's a planet that's smaller than Earth. So just the scale of things is just ridiculous. Okay, so this is the map of Mars. So we took the elevation and then just put it into a map. Again, you see Valles Marineris there, the 3 volcanoes, Olympus Mons. Giant impact crater. It's called Hellas Basin, right? Again, blue is low and red is high, with white the highest. And one thing you notice is that on the south, the southern hemisphere is all cratered. And the northern hemisphere is less cratered, right? Which is curious. But I'm going to hire all you guys as the chief engineers for the Mars Science Laboratory, right? I'm going to ask you a tricky question. So this is our Mars Science Laboratory, stuck in a shell coming down with a parachute, right? Where would you land it? Would you land it somewhere high, or would you land it somewhere low? Knowing the fact that, knowing the fact that you have to slow down before you hit the ground, and you have a parachute. So if you're at high altitude, you don't have much elevation, right? Not much. And if you're going low, you have a lot more atmosphere. So everybody knows where we're going to land. Where are we going to land? High or low? Low! Exactly. You have to land somewhere low. Good. So let me actually move that out of the way. Let's see it. Oops, where did it go? There it is. Okay, so we know we're going to land somewhere low. Now, we have to decide if we're going to go high up near the poles or staying near the equator. When you live up near the poles, it gets really hot in the summer and colder in winter, so you have high temperature fluctuations, right? And imagine temperature fluctuations like if you take a little piece of metal and you do this, right? If you have large fluctuation, will the metal break?
Yes.
Your paper clip will break? Yes, right? Versus if you're in the equator, the temperature fluctuations are a lot less. It's like taking the paper clip and doing this. It'll last a lot longer instead of going like this. Right? So, do we want to land at high latitudes or near the equator? What do you think?
Near the equator.
That's correct, that's correct. So we want to land somewhere low and near the equator. So it turns out, tap the screen, Mars Science Laboratory is going to land there. It's called Gale Crater. It's inside a crater, and you can see that it's purple there, so it's really low, and it's near the equator. But I mean, we could land somewhere here too, right? It's near the equator, it's really low, but then it's kind of boring, there's not much there, right? We want to land somewhere that's so exciting to do science. And this Gale is very exciting to do science for reasons we'll understand in a second. But first, what is the dominant rock type of the surface of Mars? We talked about it a few slides ago. Yeah. Igneous rock, it's basalt, right? Here's an example of an igneous rock on Earth. This is actually the Columbia River, which separates Oregon State and Washington State. And tap the screen. And where do you go? Oh, there it is. And then this is an example of igneous rocks, right? This is basalt. You guys heard the term basalt?
No.
Right? This is all lava flows that have been solidified. Right? So you have a lava flow here, lava flow on top of it, and on top of it, on top of it, on top of it. You have like probably 10 lava flows stacked on top of each other. Which one is the oldest? The one at the top or the one at the bottom? Oh, so many people know the answers. Yes?
The one at the bottom, because everyone will keep stacking on top
That's
of it.
very good. Yes, that's a common principle in geology. Often, not always, but most of the time, what's at the bottom is the oldest. Okay? Here's another trick question. Oops, there it is bigger. Where is this?
Oh my god.
Yeah? Grand Canyon. What you see here is the Colorado River, and it has a bunch of sand in it. So imagine the Colorado River that's just like a sandpaper, continually on the rocks for thousands and thousands and thousands and thousands and thousands of years, and it cuts right inside the rock. And you see layers here as well. Right? You see all these layers? Which layer is the oldest?
The bottom.
The bottom layer is the oldest, right? In fact, it's almost 2 billion years old down here. And then up here is probably 10,000, 15,000 years old, right? So if you want to know the history of this area, and you're a geologist, which means you know how to read rocks. Rocks tell you information about the environment they were formed in, right? You go at the bottom, and then you're in a stable location, just go up. And you're able to read the entire history of the area, right? So this is why we're going to Gale Crater. Because we have the mound over here, which has a bunch of layers, right? So we can see the entire history of Mars just because the layers are there. So let me put this button. There it is. And then I think I can flip it upside down. Upside down. And then that's the same picture. You can see the mound here. It's the mound here, right? You can see the rim of the crater down here, which is this. And the Mars Science Lab is going to land somewhere in there. I'm not quite sure where. But somewhere in here. And then it's going to drive and try to go up that mound. Because at the bottom of the mound is where the oldest rocks are. Example of rocks that exist there is sulfate. An example of sulfate rock is one that's called gypsum that you may have seen in lab.
Oh, yeah.
Gypsum, right? Right? And then you go up through the layers. That means you go up in time and you can see the entire history of Mars written over there, right? So that's why we're going to Gale Crater. So it's a cratered planet. And it's also cool because you can say a lot about the surface of the planet and the geology there just by looking at the map, right? But one of the key things I want you to remember is that in order to understand other planets, one planet in particular that we need to understand is this one. You guys know what this is? Earth!
Right here.
Yes! Exactly. This is Earth. So we are here, right, somewhere here. And again, so blue is low, brown is high, white is highest. And just by looking at this, you can already see some very interesting things, like these things. You guys see that?
Yeah.
Right? These are all parts of the Earth jigsaw puzzle. Earth is built of different pieces that move relative to each other. And the reason why Earth is the way it is because these pieces have been moving and pushing and hitting each other in ways that are not very nice. For example, there's a plate here, right? And it's actually diving underneath this plate, which is why you have the mountains there. This is the Andes, right? A bunch of volcanoes. And let me show you this slide, which shows you kind of what all the plates are. Again, you have North America here, we're here. Right? In the Pacific Northwest, where Seattle and Portland are, there's a lot of volcanoes. Have you guys heard of Mount Rainier, for example? Right? Big volcano. And that's because the Juan de Fuca plate there is diving under the North American plate, and we have a bunch of volcanoes. While here, near San Francisco, we have the Pacific plate that's actually moving like this with respect to the North American plate, which is why you have a bunch of earthquakes from time to time. You can also understand why the Himalayas are above India, because the North American plate is ramming into the Eurasian plate. I mean, the whole landforms of the Earth can be explained a lot by these different plates, right? But these plates have another important, very important role in that they keep the temperature of the Earth under control. Think of the Earth like a bathtub, right? There's water inside. And the volcanoes and humans are pumping what's called greenhouse gases into the atmosphere, right? So that's you switching on the tap. And through a complicated mechanism, all the oceans and the Earth can pull down this greenhouse gas, and using these plates, send it back inside the Earth, right? So there's a balance between the volcanoes and humans pumping gas out, and the planet itself bringing the gas back down. Okay? So that's where the problem. Have you guys heard of global warming? Yeah, it's a big problem. That's because the humans are pumping a lot more up than the Earth can suck back down, right? So that's a problem. Keep that in mind. It's important. Let's talk about Earth a little bit more, because as I said, you need to understand Earth in order to understand Mars. This is actually a picture of Earth not taken by any satellite. It's a picture taken by a human being. right? An astronaut. They were coming back from the moon in 1972, and they didn't have any iPhones or digital cameras. They're all like, and I was able to capture the entire moon, Earth, which is a spectacular picture. So what I'm going to do now is just outline the planet, right?
Oh my god.
And tell you that it's about 7,900 miles in diameter, right? And so my question to you is, how thick is the atmosphere? Is it this thick? Is it that thick? Is it thicker? Who thinks it's thicker? A few of you thinks it's thicker? Who thinks it's thinner? Maybe it's something this size? Who thinks it's this size? Yeah? Who thinks it's thinner than that? Nobody. You do. Well, actually, the atmosphere is this size. It's 60 miles high, right? So think about this. We live on a big planet. It's a very, very, very thin layer of air that's keeping us alive, right? That's why we need to spend a lot of effort to keep it clean, because there's not a lot of it that we can live on. Now, 60 miles is how thick the atmosphere is, and it's this line. So my question to you is, what about our oceans? Right? Our oceans, on average, are about 2.5 miles deep. I don't have a pen thin enough to draw the oceans on this picture. That's how little there is. So we have to be extremely careful on how we manage our resources on our planet. For you guys' future as well, because you still have a long life to live. You want to be able to breathe clean air and not have to go to the sea and be, have your skin damaged by pollution. There's not a lot of stuff that's keeping us alive. So take care of it, essentially, my message. But let's go back to the planets. Remember this is
Paradise.
This is
Earth.
This is
Jupiter.
This is Venus. This is Venus. Venus is about the same size as Earth. Jupiter is a lot bigger, right? You guys know that. It's a huge planet. So Venus is about the same size as Earth. So you can see Mars is a lot smaller. But what happened to Venus? Remember I was telling you that all these plates move, right, on Earth, and they keep the temperature of the Earth under control? Well, they can move between each other because they are lubricated, right? And the lubricant is water. Water allows those plates to move. If you don't have any water, those plates lock. So there's no way for the Earth to bring back those greenhouse gases back inside the Earth. And yet the volcanoes keep going, and they keep pumping, and they keep pumping, and they keep pumping greenhouse gases into the atmosphere so that there's so much of it. Venus is a hell house. This is the only picture of the surface of the planet Venus, right? Because the surface temperature, because there's so much greenhouse gases in there, is 900 degrees. It's a little warm to go for the beach, right? This is the spacecraft that took the picture. It lasted about 10 minutes before it got completely fried. And there's so much gas up there, like the pressure, the surface pressure is 90 times what we have here. What does that mean? That means it would be the same pressure if you were about 300 feet underwater. You know when you go swimming and you dive a little bit, you can feel your ears hurt?
Yeah.
You guys all experience that? And that's under this much of water, right? So imagine if you were under 300 feet of water. That's the pressure that's currently on Venus because there's just so much gas. Yes, Sam?
You have 8 minutes.
I have 8 minutes. Thank you. That's good to know. So this I want to talk about Mars a little bit. Mars is different because we see these kind of things. What does that look like?
Rivers.
Wow. I was going to give you a hint. Because on Earth we see rivers too. That's correct, that's rivers. But, so Mars in its early history probably had water. Right, exactly. So what about aliens? Let's think about aliens. Because everywhere we find water on the surface of Earth, we find life. But can we think about aliens on Mars?
No.
Why is that?
Mars.
Well, here's the reason. Everybody take a deep breath. And the reason why it started to become difficult is because you're running low on air, right? And if you put air in a bottle, it has different things in it. The same reason as a lemonade has water and lemon juice. Air has gases that's called oxygen. That's what you burn in your body to keep you alive, right? You eat, that's the fuel, and you need oxygen to burn the fuel. And there's no oxygen on Mars. Therefore, there is no alien. Right? Any life form that's bigger, that you can see with your own eyes, whether it's a bee, a scorpion, an elephant, a whale, whatever, any life that's bigger that you can see it, doesn't matter where it's from, requires oxygen. If you don't have oxygen, there is no big life. You can have microbes, like these guys, which are tiny. If I put all this on my finger, I won't be able to see them. They're so small. And because they're so small, they don't need oxygen. And what's exciting is that, have you guys looked at the mineral olivine?
No.
So this is a piece of basalt. You guys know basalt. And it has a bunch of minerals, one of which is called olivine. And basalt is all over Mars, as we've seen. And if you mix water with it, you get another mineral called serpentine, which is the California state rock, and a gas called hydrogen. And those bugs love hydrogen. So we know that we have water on the history of Mars. We know that we have igneous rocks on Mars. If we can find serpentine, then we'll know there's hydrogen, which is food for the microbes, right? And my good friend Bethany, which is a very good friend of mine, very cool, she found serpentine on Mars. Therefore, it's very likely that there was hydrogen there. So that's why it's exciting to go to Mars, because the fact that there's potentially hydrogen there, life could have taken advantage of that. Right? So to understand how those microbes work with water and rock, we have to go to where there's a lot of water and a lot of rock, which is at the bottom of the seafloor. Right? And to do that, you need a boat. This is me. Who's boat? Big boat. And the boat has a submarine. You can see like the robotic arms. Right? And a bunch of different tools. The pilot goes in there. That's the boat that takes the submarine, that's going to dump it into the water. And then that's me inside the submarine as we go all the way down to the seafloor, right? And you can't see it because there's not much light in the sun. And what I want to show you guys is this work. Nope.
Sorry, was that the animation?
Yeah. Yeah. That was the animation. That's okay. That's good. So let me go back one.
Very good.
No. That's fine. I can show it to you afterwards. But I just want to finish the talk to talk more about aliens, because I know you guys are interested in that, and I would love to. Hi! 5 minutes. Thank you very much. I'm almost done. Let's talk about aliens for a second. First, you guys know all about the galaxy.
Yeah.
Right? This is our galaxy, the Milky Way. Right? Huge. It contains probably 1 billion stars, like our sun. We live at the very edge of it, thankfully, right? And if you go camping with your parents, or if you go somewhere that's really dark, and you have a clear sky, sometimes you can see that Milky Way. Right? This is a picture taken on Earth, right? Now, this picture has been enhanced a little bit just to show more details. What you actually see with your own eyes is kind of this drapey white band. Have you guys, anybody seen it? A lot of you have. That's awesome. Yeah, so that's Milky Way. This is our home, right? But if I use the most powerful telescope in the world, the Hubble Space Telescope, it's a telescope that's orbiting the Earth, right? And have it just stare at an area of the sky that's as big as this red dot, right? Relatively speaking, on the scale. What the Hubble Space Telescope will see is this. Every single dot that you see there is another galaxy, other than ours, right? So the homework I'm assigning you guys tonight is you grab your parents outside, right? And you take a dime, right? And you go outside to the sky, to the night sky, and you just point the dime in the sky like this. And you say, Mom, Dad, behind that dime is this. Billions, well, in this picture not, but hundreds of different galaxies separated by distances of hundreds, thousands of light years behind this dime. So now I'm asking you, imagine how many there are in the entire sky. Yes. It's a number that we can't even imagine. So here's my question to you. Based on this knowledge, do you think we're really the only living species in the entire universe?
No.
I think it would be kind of egoistical of us to think that we're the only ones, given the size of the universe. Right? Whether we can talk to them, who knows? But that's all I have to say. So, thank you very much.
We have 5 minutes for questions.
Mr. Hill, can you help me with questions?
Oh, sure. Well, I will let you, I would just look for the student that's sitting quietly.
So somebody that's not moving much, that's kind of quiet, that's not okay, let's see let's see, how about this gentleman over here?
Well, you know there's brighter ones and then there's the darker ones? Are the brighter things like the sun?
No, so those are galaxies, those are not stars, right? In each galaxy, there's like almost 1 billion stars, right? Remember the picture I showed you of just our galaxy with us on the edge? Imagine that galaxy is actually that one. Whoops. I touched it. Oh, go back. So anyways, you see what I'm saying, right? It's yeah. Okay. Small, quiet hands. The lady in the back.
Doesn't the stars like change color as they like go on? Because some of them explode, you know, like.
Yeah. So in fact, even our sun is changing. Our sun is slowly getting brighter. Slowly getting. Does that mean it'll be nice and warm outside tomorrow? No.
Yeah.
What it means is that in 1 billion years from now, it'll be too hot on Earth for there to be water. Right? So the water will start to evaporate. Those different jigsaw pieces are going to lock. The volcanoes are still going to be pumping greenhouse gases, and Earth will become like Venus. That's in 1 billion years from now. Don't worry about it. Sir in the back. Yes.
If that happens, will humans be smart enough to find a different galaxy to go to?
That's your job. You get to become scientists and invent warp drive, like spaceships, so we can go explore the solar system. And I'm pretty sure that within our lifetime, you and me, some human beings from Earth are going to be starting to explore Mars, actually walking to Mars. But again, it's not going to happen tomorrow. Maybe when you guys are Mr. Hill's age.
That's pretty young.
Wow.
No, it's not.
Lady here. Yes.
So will humans be extinct if the water starts to evaporate?
If we stay on Earth, yes. But we're pretty clever. So I'm pretty sure we can start colonizing beyond. Yeah.
Are they like half the size of a grain of sand?
Oh, they're smaller than that. Because you can see a grain of sand, right? These guys, there's one on your hand. It's there, but.
And the other one is the other galaxies also have planets or
Other
the other galaxies have planets or
Yes, that's a very good question. In fact, the place on Earth who are the experts in that is down the street from here. And NASA Ames, there are scientists who have a telescope that's looking at stars, right? But they just look at stars for a long time. And sometimes you see the brightness go doop, doop. And that's because it's a planet was in front. And they were able to find, like, they have more than 1,000 planets that are orbiting stars that are not our sun. That's crazy. Who has not asked a question?
So if you've asked a question, guys, put your hand down just so we give everyone a chance, okay?
You already done.
So I have.
No, you asked a question.
Yeah.
Okay.
Well, I kind of
You
have.
didn't? I'm sorry, we'll get back to you.
I kind of have like a comment, but my cousin, she's in high school, and she said that like scientists have found like little tiny not like
Pieces of
germs.
comments?
No, like germs or something. I don't know, that were like alive or something.
We have not found any life that is not from Earth, right? If you read in the paper, some crazy person has detected life somewhere else, don't
Don't
believe
go
it.
there.
I'm sorry, yes.
So, 2 questions. One, No, there's nothing on Mars except for things that I can't even see. Why would we keep studying?
Because the possibility of having life that's originating in a place that's different on Earth, I think is very exciting. Because that would tell us that life is not unique to Earth. In fact, it could exist even in our galaxy. We don't need to have to go really, really far to find it. And if it's very different from us, it will help us understand who we are, right? Where do we come from? Are we even tied to these things? Right? It's a very good question. It's not easy to answer in just like that, because it's a very fundamental question. It has a lot of implications for how society views ourselves. Yes?
If you use a microscope, can you see anything as small as atoms?
Depending on which microscope, but that's correct, yes.
I see, Dr. Som, I just wanted to help you out.
Yes.
I see 3 hands. I see Joey, I see Hannah. I'll make it 4. Maya and Jasmine. So,
Maya asked a question.
oh, you didn't? Okay, so I'm just asking folks with Joey, Hannah, and Jasmine, because we need to be respectful of Dr. Som and Ms. Dueck's time, because we're going to go talk to Mr. Marcus's class next. So let's take those 3 questions, and then we'll call them after, okay?
Does Mars orbit like Earth?
Nope, Mars orbits the sun, like Earth. So it's a bit further away, so that's why it's colder. And both of them are orbiting the sun. Who was this?
Oh, we have Hannah.
My question is, do you think we'll ever colonize on the moon?
On the moon? Oh yeah, we'll see it. You'll see it on CNN in like 30 years. We're going back to the moon. I'm pretty sure. One more question.
And we have Joey.
Joey.
Joey, thanks for being patient.
Have you ever seen a rover in person? Have you ever seen a rover other than in a picture?
Yes, I've seen the Mars expression. I haven't seen it myself.
Very nice. I'm going to ask, boy, I'm not sure I should ask this or not. I would love to get a picture of class with Dr. Som and Mr. Webb. I just love that. I'm just wondering if we could, we'd really have to max out the ABCs here, guys, okay?